Hello, everyone. My name's Paul Moayyedi, and I'll be talking today about exploring the microbiome and brain-gut connections. So a little bit about me. You may be able to tell from my accent, I am not originally Canadian. I graduated from Bristol University in the UK and did my GI training in the University of Leeds. I am a gastroenterologist and I have the Audrey Campbell Chair of Ulcerative Colitis Research. I'm also the Assistant Dean of Research at the Massey University and currently President of the Canadian Association of Gastroenterology. More relevant for today, I am the co-principal investigator of the Imagine Research Network, which I will talk about with Deborah Marshall. And what I will talk about, after introducing myself, is what the microbiome is, a bit about brain-gut connections, and then more general discussion around the studies we're doing, and not just about the brain, but also in the gut around inflammatory bowel disease, irritable bowel syndrome, and mental health. So what is the microbiome? Well, basically, it describes the bugs that go along life with us. And by bugs, I mean protozoa, bacteria, fungi, viruses, everything, really. Although research focuses on bacteria because that's what we can see most easily and is probably most relevant to human disease, although viruses may well be as well. And they're present in our mouth, on our skin, anything connected to the outside world, but also a little bit in the lung and a lot in the digestive tract, which is what we're going to focus on. The reason for that I will explain in a minute. It is an impressive number of organisms that we share our space with. They outnumber us in terms of the genetic material 100 to 1. So there are 100 more bacterial genes, for example, than there are human genes, and it's much more diverse. Actually, if you look at individual people, we are 99.9% similar to one another in our genetic makeup. We may look quite different, but actually most of the genes that we have within us are exactly the same. Whereas with the microbiome that hitches a ride with us, it is 80 to 90% different from one person to another. So huge differences there. And you could say that we are a receptacle for our own bacteria and viruses because they far outnumber us in terms of what's inside us. And indeed, there are more bacteria inside each of our colons than there are stars in the galaxy. And interestingly, the richest source of bacteria on the planet is in the human colon. We harbour far more than, say, a cow does or a mouse does. So it's a fascinating organ which we're only starting to understand. Now, I'm from the Farncombe Institute, which is a great collaboration between clinical and basic researchers, laboratory-based researchers, studying gut diseases and more recently gut-brain diseases. And we were the first facility in Canada to have a germ-free facility, one where mice were raised without any germs whatsoever, no viruses, no bacteria, nothing. They were purely the animal. It's obviously a very laborious process, but you can do it. And it's really interesting model to then study how the gut bacteria interacts with us. And the first thing I would say about this is these are sickly creatures. They are usually much thinner than their cousins who have a normal amount of bacteria. They don't reproduce well. They're just not well. And this tells us that actually the bacteria in our system are actually needed for our health. We often think of bacteria as bad, but actually they can be both bad and good or indifferent. And a certain amount of bacteria are really helpful for us and for our immune system, as I will describe the next few slides. Because what we find with the gut bacteria, this is the interesting thing here, is that the lung is mainly sterile, but does have a few bacteria in it. And it is a very thin layer when you get to the end of the lungs, because you have to breathe in air, and that oxygen is then transmitted to our blood. So it's very thin, but it's more or less sterile, so that's fine. Skin, on the other hand, is much thicker, and it has a lot of bacteria, but it's actually quite a small surface area and not as much bacteria as in our intestine. And most importantly, the skin is thick. So the bacteria that reside in our skin, unless we get a cut in it on our skin, don't go anywhere. They just stay in our skin because the surface there is thick. The intestine, on the other hand, is a vast area, about the size of a football field when stretched, and again is as thin as your lung because it's needed to be thin to transmit the nutrients that we eat into the circulation and to the rest of our system. But the problem is that thin intestine is teeming with bacteria. And there's just a small layer between our intestine and the rest of our system. And if those bacteria got into the rest of our system, they would kill us. The numbers, if you're interested, are 10 to the 15, as I say, more than stars in the galaxy. So it's not surprising, therefore, that most of our immune system is focused on our gut. And if our immune system is focused there, it probably is sensing things all the time without us knowing, keeping bacteria at bay, making sure they don't invade us, but also affecting our health in a variety of ways. And this is where the brain-gut connection comes in. Because if you think about it, our mood can be influenced by our environment. So if we're in a pleasant environment, we may be happier than if we're in a dirty environment. But all sorts of things of our external environment affect our mood. But our internal environment, our gut microbiome, may well be affecting our mood as well. We're just not aware of it because it's all mediated through our immune system, and it's not something we're so easily familiar with. But it's certainly possible. And probably, at least subconsciously, we've been aware of this all along. If you look at expressions related to the body, they're often about feelings, and they're often related to the gut. Feelings, at least in the English language, related to love tend to be the heart. But everything else, both bad and good feelings tend to relate to the gut, particularly bad. So you have a gut reaction, you can have stomach in knots, butterflies in your stomach. All of these things connect the stomach to the mind and have been in the English language for centuries. And interestingly, if you look throughout the world, there are similar phrases describing our feelings and our gut. Virtually every language that I've asked about, except the Czech Republic for some reason. So it is interesting that it is innate within us that we know that our guts relate to our feelings. But what about science? Can we prove that gut bacteria influence how we feel? Well, some of my colleagues, Chemik Burchik and Steve Collins, looked at this, started this work about 15 years ago. And others have followed since and shown that their results are probably quite accurate. But they did an interesting set of experiments. They measured behavior in mice that can mimic anxiety and depression in humans. So they used what's called a light-dark test and a step-down test. The light-dark test is mice tend to like the dark, but they also like exploring. So they will go out in the light to explore, but they will tend to spend most of their time in the dark. You can measure whether a mouse is adventurous or timid depending on how much time it spends in the light compared to the dark. The same sort of idea is a step-down test. So you put a mouse on a platform with water but underneath, not much water, not that good, but mice don't like water, so they'll tend not to go in it. But after a while, they'll get bored, they'll want to explore, so they'll step in the water gingerly. And the time they take to do that, again, tells you how timid or adventurous they are. And Dr. Collins and Dr. Burchik also use the fact that not all mice are the same. So NIH Swiss mice are naturally brave, Bob C mice are naturally timid. So what they did was they took some NIH Swiss mice that are naturally adventurous and looked how long it took them to step down from the into water, which was 20 seconds here. And they did the same with Bob C mice, and it took 280 seconds before they stepped down. Okay, they then looked at the germ-free mice, and it's important to have germ-free mice for this experiment, and they were the same. So obviously this is an innate characteristic within them. And it's important to emphasize that a lot of this is innate, our life experience, our genetics that do this. But now we have germ-free mice that are doing the same sort of thing. We can introduce the bacteria from a timid mouse into an adventurous NIH Swiss mouse. And when you do that, they become more timid. And when you do the opposite with a Bob C mouse, you give them an adventurous mouse's bacteria. Don't forget they're germ-free at the moment. So you give them these bacteria, they become more adventurous. So this is really the first experiment to show the bacteria within us can influence our behavior and our mood. And they carried on doing that work, and one of the bacteria that seemed to drive this in their experiments was a bacteria called Bifidobacterium longum. So this was work that Dr. Burchik and Dr. Collins were doing with Nestle, and Nestle then created this probiotic, this type of Bifidobacterium, and we looked at it in people. We took people who had IBS but were also anxious and or depressed, and we randomized them to have either the probiotic, Bifidobacterium longum, or the placebo. And the interesting thing was that the end of the study, the depression and to a lesser extent anxiety improved in the probiotic group compared to the placebo. Almost twice as many people in the probiotic group had an improvement in their depression compared to placebo. It did improve the IBS symptoms as well, but less dramatically than the effects on depression, which suggested it wasn't just making the symptoms better, it's probably having an effect on mood itself. And interestingly, you could actually see this on functional MRI changes, which looks at the function of your brain. I can't interpret these images for you. I'm not an MRI expert. Basically, those that can say that signs of a good mood were seen in those taking probiotics, which you didn't see with placebo. So this is early studies that suggest this probiotic may help mood. Now, I'd emphasize a small number of patients. These results are very fragile. They may or may not be real, but it is fascinating and may suggest that we can alter gut bacteria within us, and this may help our mental health, particularly in those with GI disease already. And so with Nestle, we are doing a larger study looking at this probiotic or placebo, following people up for 6 weeks. And hopefully in this larger group of nearly 200 people, we will show definitively whether this works or not. And if you're interested in taking part in that study, if you have irritable bowel syndrome and feel you might be a bit anxious or depressed, we're looking for mild to moderate anxiety or depression, then these are the sites that are recruiting. Hamilton is recruiting now. Edmonton, Calgary, Winnipeg, and St. John's will be recruiting in the very near future. So moving on to GI diseases. So it's a bit of a stretch to think that your gut bacteria can affect your mental health, but it appears like it might be true. It's not so much of a story. So it's not such a stretch that your gut environment can affect your ulcerative colitis, a gut disease like ulcerative colitis with inflammation shown here. And it's not too much of a stretch to think that either the diet you eat or your gut bacteria may affect that inflammation, may cause that inflammation. The question is which it is. In looking at what might be causing this, if it's food, ulcerative colitis is an inflammation of your colon that starts in the rectum. Most of your food, or all of your food, has been digested by then. So it's unlikely to be food that's the direct cause of ulcerative colitis, but it could be bacteria because your rectum is rich in gut bacteria. So we study this with fecal transplantation. So we took what we aim to do is find, we believe that people with ulcerative colitis have that healthy in their gut, and we can change it to healthy bacteria. By giving stool from a healthy person, and we do that once a week for now at the moment 8 weeks. And we did a randomized trial of that in roughly 40 patients in each group. And we found that roughly a quarter went into remission, much more so than in the placebo group. So I, on my screen, am getting a lot of yeah. So the bottom line is that there did seem to be a benefit, and interestingly, there was one donor that had a lot of successes, and other donors not so much. So it may be something in the bacteria that we're giving that's important, and we need to study this. We don't know what that is yet, but it is. We have right. So there is something about the donor. So donor B is this donor here, but we don't really know what it is. And by the way, donor F had a success, and so I don't think it is just donor B, but there are certain donors where things don't work and other donors where they do. We need to do more research to understand what that is and hopefully make this treatment better. But also, people with ulcerative colitis often have more anxiety, do have more anxiety and depression than the general population. And maybe it's these gut bacteria that are also doing that as well. And we will try and work this out. And here's just an example of one of the patients in the study who had very bad disease throughout his colon. And after 8 weeks, this patient was actually not one that contributed to the positive result, because at 8 weeks they still had some inflammation, but it was much improved, so we carried on. And by week 12, they were in remission, and here's their colon at week 20, which was no inflammation at all, either looking or when you take samples. So the inflammation had gone. So this is a promising therapy, which works in a very different way from previous therapies for this disease. But the challenge is, you need to know which patient respond and why. Right, which patients respond and why? And like I said before, the trouble is there are so many bacteria in your system, it's very difficult to work that out. You need large numbers to do this. And this is where the magic cohort comes in. So we're recruiting people across Canada with either ulcerative colitis, Crohn's, irritable bowel, or just healthy and well. And what we're looking at is what, particularly diet and gut bacteria, how that influences the GI diseases, but also how it influences mood, particularly those related to GI diseases, but also in healthy, we're looking at that as well. And we're close to finishing, but we're not there yet. And basically, the study involves figuring out a questionnaire, giving a sample of stool, urine, and blood. And from that, we should be able to work out what bacteria are driving mood, and what diet might be helping that as well as these diseases, inflammatory bowel disease, irritable bowel syndrome. And so far, we're nearly 7,000 subjects, lots of samples. And we'd love for more people to take part. These are the areas that are co-recruiting there: Edmonton, Calgary, Winnipeg, Montreal, Ottawa, Kingston, Hamilton, and Halifax. So if you're near there, please come along and volunteer for the research. But the reason we're doing this is to understand better these GI diseases and mental health and the connection between the two. And why it's important and why you need these big studies is exemplified by Framingham, a town in Massachusetts that you've probably never heard of. But after the Second World War, a group of clinicians got together and decided that they would do a study of about 5,000 people to see what was causing heart disease. And the town is very proud that it participated in that and continues to do so. And from those beginnings, with those large numbers that they followed up over time, we now know that smoking can cause heart disease, that blood pressure can cause heart disease and stroke, and that cholesterol is bad for you. All of this relates to the Framingham Heart Study. So things that you know now relate to this study that went on and is still going on in Framingham today. 70 years so far, and nearly 4,000 publications. But like I said, the most important thing is that we now understand a lot more about heart disease than we did before this study started. And it's not the only one, I would emphasize, but it was the first of its kind. And we want to do the same in GI disease. And with that, we hope we will discover the cause of things like Crohn's, ulcerative colitis, and IBS, and make life better for people suffering with these and their mental health problems as well. So please keep calm and donate poop. And if you are interested, this is the website you can go to find the centre near you. And I would be happy to take any questions. Thank you.
Thank you, Dr. Moayyedi. I'm Ida Fernandez, the Executive Director for the Imagine Research Network, and we do have some time if people would like to enter their questions into the chat box. You can type them directly there, and we can direct those questions to Dr. Moayyedi to answer. In the meantime, maybe while you're thinking about what questions to ask, I just wanted to prompt the discussion, and maybe Dr. Moayyedi, if you can talk a little bit about what other areas, disease areas that fecal transplantation is currently being studied in to see if it has an impact in health.
Yeah, thanks, Alan. There are a huge number of studies that are ongoing in this area, usually small and often not well funded because this isn't supported by the pharmaceutical industry, but it's looked at in autism, in multiple sclerosis, just to name a few diverse diseases. I think it's an interesting area to study. It's also thought that it might help obesity as well, because there are other studies that show gut bacteria can drive obesity. Like any area of research, my prediction is that many of them will not pan out, particularly the obesity one. It'd be lovely if you could take a little probiotic and get thin again, but I don't think that's going to happen realistically. But with autism, MS, who knows? But what I do think is anything that's strongly connected to the immune system. There's a lot of autoimmune diseases, most of which you've probably never heard of, but they may well be all relate to the gut. So things like rheumatoid arthritis, that's where your immune system attacks your joints. Well, maybe it's doing that in a signal from a bacteria in your gut. Maybe if we could find out what that is and remove it, we can stop our rheumatoid arthritis. So I think there are all sorts of fascinating areas of which fecal transplantation is just the avenue to explore it. You know, I think the field is exciting, but we've got to take perspective. Not every disease is going to be cured by fecal transplant therapy.
Thank you, Dr. Moayyedi. If you can talk a little bit about what is known right now about gut health and schizophrenia spectrum disorders.
Yeah, that's a great question. Well, Val Taylor is doing some work in this in Calgary. But yeah, we don't know enough about their gut bacteria and schizophrenia and schizoaffective disorders. We do know the gut microbiome is very different, but there's a cause and effect here. The problem is once you have schizophrenia, our life alters quite significantly, and this may also alter your gut bacteria. And no one, as far as I'm aware, has tried modulating that to help schizophrenia. Well, there may be one FMT study looking at that, I'm not sure, but it's certainly one. I talked about Val Taylor, she's mainly doing it in anxiety and depression. But I do think it's interesting, and I do think that infection may play a role, but it may more relate to a regular infection that's affecting your brain than a gut microbiome interaction. But who knows? It's as yet poorly studied and would be another interesting avenue to look at.
Thank you, Dr. Moayyedi. We have another question here regarding probiotics and prebiotic supplements. Do they survive the stomach acid?
Well, a prebiotic is basically food that promotes the growth of good bacteria. So yeah, that does survive stomach acid, just as food generally does. It may be altered a bit, but often not much. So yes, prebiotics, there is no issue, or little issue. Probiotics, and often the two are combined, by the way. Probiotics are living bacteria that promote health. That's their definition. And so you're right, stomach acid is designed to kill them. But, we have a ton of bacteria in our gut. So that tells you right away that acid doesn't completely do what it's supposed to do. And the reason it doesn't is that when you eat food, that tends to neutralize the acid. And therefore things do get through. Now, of course, you often don't have probiotics with food, but maybe you should. But they don't often say that, because what you do is you encapsulate it with an acid-resistant capsule that then dissolves when the pH is more normal in your intestine. So that's how they get around that. So that most, but not all, because you're right, some of them probably will be killed in the very adverse stomach environment, but enough will get through to allow it to populate the small intestine and probably to a lesser extent the colon. However, what I would say is probiotic industry is not regulated in the same way as drugs are. So just because they say, this is what it is with this amount of bacteria, doesn't mean that's what it contains, because there is no body checking that what they say is true, nor do they have to get Health Canada approval to release it onto the market. So Richard Fedorak in Edmonton looked at this, about 15 different probiotic preparations in Canada, and none of them had the amount of bacteria they said they had in them. They all had a bit less, and that sort of makes sense, because when they're on the shelf, gradually it dies off. But more importantly, some of them had no live bacteria at all. A few didn't have any live bacteria in them. The bacteria had all died. And in one, there was no bacteria ever in there. It was truly a placebo. It was basically fraudulent. This just goes to show the problem with this industry. It's not to say probiotics are bad, far from it, but because they're unregulated, it's difficult to know whether what you're taking is what it says on the tin, as it were.
So along the same lines, we have a question here. Are there any probiotics that you would recommend for optimizing gut health?
Yeah, so gut health is a tricky term. It's a great question, but a tricky thing to answer. Because, it's just like saying, are you healthy? And you say, yes. Well, what does that mean to you? And probably gut health looks very different to different people. And so I don't think it can be easily answered, because it's such an amorphous concept. And when you're talking about using it for diseases, it probably depends which disease as to which probiotic you should use, but also what your gut bacteria look like and what probiotic may work for you. It's probably where we're at, probably where we will go, but it's not where we're at now. I like to liken it to antibiotics. So we've had antibiotics since the Second World War, but they've been much more heavily studied. And what we know is that this bacteria will respond to this antibiotic. We don't have the same knowledge with probiotics. We don't know what gut microbiome will respond well to what probiotic, but it's probably different in a different person. And so this is one of the ways in which we hope that the study I was just talking about, MAGIC, will help us understand, because we'll have much more information about what gut bacteria are doing what, and in healthy and in health and in disease. But we were still far away from being able to answer that question well. What I will say is most probiotics are derived from an observation made in the 19th century that Balkans, someone in the Balkans in a mountainous area, most of them lived a long life, often to the age of 100. And they wondered why, and scientists felt it was the yogurt they were eating, which was full of bifidobacterium and lactobacilli. And today, most, not all, but many of our probiotics are either bifidobacterium or lactobacilli. but they're not the only things that confer health. So we probably need to do better than what we are currently in the probiotic sphere.
So I have an interesting question here, Paul, if you can try to answer, but this person's interested in knowing whether eating together and in community can improve our gut biome by sharing bacteria whilst we share a meal. Is this true? Have you heard of this, or is there any evidence to support that?
I'm not saying there's no evidence to support that. The accurate thing is I'm not aware of evidence that supports that, but it does make sense. There is a hypothesis that we are too clean now, and this is why there is more asthma and inflammatory bowel disease in our, the Western communities in developed countries, because the cleanliness is good, so you don't get so much salmonella and other things that really do you harm. But equally, it can be bad because our microbiome is not as diverse as it used to be, and there is some evidence for that. And it does make sense that communal eating could improve that, but I don't know of definitive evidence that shows that, but it certainly makes sense. I've got 2 children, and I certainly let them roll around in the mud a lot more than my wife was comfortable with, because I felt it helped their microbiome and may protect them from other diseases in the future.
Great. Thank you, Dr. Moayyedi. A couple more questions we have here. One person mentions, I eat a lot of fermented food and find it's improved my gut health. Why would there be benefits if it shouldn't survive the stomach acid?
Well, that's just as actually what I said. It's the same with probiotic yogurts and things like that. The clue is in the word food, so you're eating it. So, if you had a very small amount, you're right, probably everything would die off in the stomach acid. But as long as you eat a reasonable amount of fermented food, that's going to soak up the stomach acid and some of the bacteria, not all, but some of them are going to get through into your small bowel and confer health. Just like what you don't realize is all the time we're eating salmonella and campylobacter, all sorts of things, but usually only very small amounts and with food, but still it's not enough, and so it doesn't get through. But as long as you have large amounts of those, some will get through, because the stomach acid is to a certain extent being neutralized by what you are eating. So yes, in a petri dish, it will kill everything instantly, but in real life, when it's soaked up by that food, some will get through into the small bowel. And that's true of probiotic yogurt, and it's true of fermented foods such as kimchi.
So one question here asks if you can explain other factors that influence the makeup of the microbiome, such as stress or sleep. Are there other known factors that influence the microbiome?
Yeah, it's, as I said, people who are anxious and depressed have a different microbiome than people who aren't. And you can show that both changes in diet and changes in stress level will change the microbiome, both in people, but more rigorously and more, convincingly in sort of mice experiments. So you can show that that does work, and the mind itself influences our bacteria. I obviously am a gastroenterologist, so I focused on the direction of the gut affecting the mind, which it does seem to do, but it does work the other way. So your mind will change your gut bacteria and can exacerbate GI problems. And the most classic example of that is if you're very scared, you find you have looser bowel movements. It's an almost universal reaction to that. Extreme fear will make you want to go to the toilet.
Great. And just two more questions, I think, before we sign off here. One is probably similar to a previous question, but if you can inform us whether there's a link between the gut biome and bipolar disorder. And then the second one, just to wrap us up here, what are the main avenues to optimize gut health in our current era? I think that's a good one to end with. So first, if you can address the bipolar.
Yeah, so I think the bipolar question is a great one, and one again, a bit like schizophrenia, I can't answer. Although it's probably more likely to be related to the microbiome, because bipolar means you have both sort of manic features where you have, if you want of a better term, excessively good mood to a pathological degree, but also very depressed on other occasions, and it can swing between the two. And the depression element of things, like I said, microbiome does seem to be important. So it sort of makes sense that that may also apply when you go to the other extreme as well. But unlike depression, the models we have, the animal models we have, are less good. And again, it's been less well studied. But you know, as a hypothesis, it makes sense. But I would say we're far from understanding this. And even whether it's true. But it's a very good question. But I would say if we can get answers on depression, we can then extend that to a bipolar population and see how it holds. With regards to what you do to have a healthy microbiome, I think diversity is the key. Having lots of different sorts of bacteria, the more the merrier, really. So to do that, you need a diverse diet, because we are what we eat, and your gut bacteria really relate to what you eat. You could show this in studies where you change your diet. But also just in the life course, when you're a baby, it's mainly lactobacilli in your gut, and that changes as you wean and as you go to a more adult diet. But I do think focusing on your diet is the best way of keeping your gut microbiome healthy. And that means less ultra-processed foods, things like Mars bars, breakfast cereal, things that are highly processed. More, the vegetable and fruit thing is always good, but also pulses, things like lentils, chickpeas, that type of thing is good for black, beans, that type of thing. So actually, we probably don't eat enough, and is going to be good for your gut health. And yes, meat is fine, but actually in more moderation than we have. We probably eat too much meat, too little, and too much carbohydrate, and too little pulses, fruit and vegetables, and we probably need to focus on having more of that. But as one of the other questioners said, fermented foods are great as well. It's a good thing to eat.
Great. So I just want to thank you, Dr. Paul Moayyedi, for your presentation today, and I want to apologize again for the group for the unwanted photos, explicit drawings that popped up here. We'll definitely do our best to try to manage that in the future, but really appreciate everybody's participation today and your very insightful questions. We hope you've found this webinar informative. And if you'd like to participate in our research, please do visit imaginespor.com. They're great opportunities for individuals that are not affected by IBD or IBS, just a healthy control to really help us answer many of these questions around the connection between the gut microbiome and our health. And we would certainly love to have you part of that research. So please, again, just visit our website. You can email us. You'll find our contact information there, and we'll try to connect you with the closest recruitment center, hopefully in Canada, that you're able to join in. So thank you all. Have a great remainder of your day, wherever you're coming in from. So take care.
Thanks, everyone. Bye.
Thank you.